Okay, in this problem, I have this beam right here, this green beam, and it's being pulled up by a crane, and the crane is pulling it up with a force of 28,000 plus 3,000 s squared. So it's being pulled up with a force that's a function of some distance. And what I want to figure out, I want to determine its velocity. So its velocity is equal to something after it has risen 3 meters off the ground. So I'm going to also say that because it's rising off the ground, this is going to start from rest. And this is very important, starting from rest. So with this problem, this beam is being lifted up this way, so it's moving in the vertical direction. And what I'm pretty much asking is, after it's risen 3 meters off the ground, so if this is 3 meters from the ground, what's its velocity at this point? That's all I'm asking. And with this, we can use the principle of work and energy, which says that our initial kinetic energy plus the sum of all the work from point 1, which is the ground, to point 2, so the sum of all the work of all the forces is equal to the final kinetic energy. And we know that the kinetic energy, T, is equal to 1/2 mass times the velocity squared. So if we account for this equation in our problem, we're going to have T1 plus the sum of all the work from points 1 to 2 is equal to a final kinetic energy, so T2, and our T1 is going to go to 0 because it starts from rest, so our initial velocity is 0. Now, we can look at what T2 is. We know T2 is going to be 1/2 times mass times some velocity. Well, we have our mass. We know our mass is 2,500 kilograms times some velocity squared. And we could figure out what all the forces that do work on our system are. If we look at a free body diagram, this yellow line, this is just the supports that's pulling this beam up. We're going to consider that they are massless, but we have a weight that goes down of this beam. The weight is equal to this 2,500 kilograms times 9.81, which is gravity, and this is equal to 24,525 newtons. And we also have the force from the crane that's being pulled up, and we're told that this force is equal to 28,000 plus 3,000 s squared. Okay, so let's deal with our force of this work, of this weight first, because this weight, it's easier. So the work done by the weight is equal to minus the weight, which is minus the weight times the change in height. So this change in y. Well, the minus weight, it's going to be minus 24,525 times this 3 meters right here. Here's our S2 position, here's our S1 position, so this is just equal to 3. This change in y, this 3 meter height. And so this is equal to minus 73,575 joules. Okay, so now let's look at the work done by this force. And we know this is going to be the work done by our variable force. So the equation we have for this, well, it has to still be that integral. So from S2 to S1, the force times the cosine of theta times ds. This is the equation we have for our work of a variable force. Now, if we modify this equation right here to fit our specific problem, we notice that this cosine of theta is just going to be equal to 1 because the force is being applied in the same direction that this is moving. Its force is being applied in the vertical direction, and our beam is moving in the vertical direction. So it's the cosine of 0, and the cosine of 0 is just 1, and so this just sort of goes away for all intents and purposes. So this is going to be equal to, our S2 is 3, so the integral from 3 to 0, our S1 is the ground, which we're going to call 0, times F, and F is 28,000 plus 3,000 S squared times ds. So if we evaluate this integral, we're going to get 28,000 S plus 3,000, what's S cubed over 3. And this is going to be evaluated from 3 to 0. So this is going to be equal to 111,000 if we plug our bounds in. So this is 111,000 joules. Okay. So if we plug this in, we're going to have 111,000 joules plus this minus 73,575. And if we solve for v, which is right here, we're going to get a velocity which is equal to 5.47 meters per second. And this is how fast this is moving when it is 3 meters off the ground.